Alright, 2018 Unit 2, Paper 1. Which of the following is a sketch of the locus of the point represented by the complex number given that z minus 5I, we know when we're looking at locus, we need to have z take away the modulus of a plus ib is equal to r. So I need to put z take away, a could be 0, and I'm going to have plus 5I is equal to 3. Radius going to be 3. All of these answers will have a radius of 3. I'm looking for the center. The center is going to be AB, so the center is going to be 0, 5. So 0, 5, the answer is B. Number 1, pick up that all that, yes? Alright. Number 2. The roots of the equation, or some of our calculator might be able to work this out, and if it could, then big up. The roots of the equation x squared plus 1 is 0, so I know x is going to be plus or minus the square root of minus 1, which is plus or minus I. D is the answer. This is where Oligon and Cosma. Given that z is equal to minus 1 plus root 3I. Actually, this is not where Oligon and Cosma. The exponential form of the complex number is square root of 1 squared is 1. Well, I ain't gonna bother to calculate that because all of these have 2 as the modulus of z. And then we have to calculate argument. So the argument of z is equal to, let me calculate the, now I know in the past, I would have told you guys, calculate this thing called your reference angle, right? And the principal value. But because in pure maths, we have something called a principal value, I'm going to change what I told you guys way back when, all the way back in Add Maths. Instead of saying the principal value, I'm going to now rename that to be the reference angle. So we know that how this complex number is minus 1 plus 3 is over here. That's where the complex number is. So once I calculate the reference angle, which back in the day I used to call it the principal value, I'm going to say, nowadays I'm going to say reference angle is tan inverse of root 3 over 1. Tan inverse of root 3 is pi on 3. And in this piece of the graph, if the complex number lies there, then the argument, is going to be pi minus pi on 3, which is 2 pi on 3. So which one gives me 2 pi on 3? The answer is D. The derivative of ln, oh gid. This is a nasty question. Alright, so I have to differentiate the function. So this is going to be the cube root of x, that is x to the minus a third. Alright, so I have to differentiate this, which is minus a third x to the minus 4 over 3. When I differentiate this, I need to divide it by the original function itself. And the original function itself is this. This is the original function in index form. So when I divide by x to the minus a third, I'm going to get minus 1/3 x to the power something. I don't have to really look too hard because this is the only question that has a minus 1/3 as an answer. I just want to make sure when I have the powers here, I must take away the powers when the bases are the same. So I'll get minus 1/3 x to the minus 4 over 3, take away minus a third, which is plus 1/3, which is going to be minus 3 over 3, which is minus 1. So I'll get minus 1 over 3x, which is indeed part 4. Alright, now this question here, we will see the repeat in this particular question, right? If they give me a partial derivative, to get what the function is, we go have to integrate. But partially integrating is not really a thing that we're familiar with, and we might make a mistake. So instead, what we are going to do we are going to differentiate each of these functions, each of the answers, and see which one gives me del f del x and which one gives me del f del y. And you will realize number 5 is a heavily repeated question coming up the road. All right, so let me get for part A, let me see what del f del x is. I'm differentiating with respect to x, so y is going to be my constant. So it's going to be a product rule, so it's going to be u multiplied by dv dx, which is going to be cosine of x plus y. So let me check one time. I'll get e to the x cosine x plus y, good. Plus plus u, which is sine x plus y by dv dx, which is e to the x. Now, this is minus e to the x sine of x plus y, which not going to work. So I know that our A is a no-go. Let's check and see what this one gives. So, del f del x is equal to, we're going again. It's going to be v, just now, del f del x is either du dv dx plus v du dx, that's fine. Del f del x is v multiplied by du dx plus u multiplied by dv dx, which is minus sine x plus y. So I'm getting del f del x. When I factorize e to the x, I get any minus sine x plus y, and I get any plus cosine. Good. So let's differentiate this same function with respect to y now. Differentiating with respect to y, well, e to the x is now a constant, so I'll just differentiate cosine of x plus y, which is minus e to the x sine x plus y. So this answer is going to be option B. And from the time we hit the second year of past papers and we see this question repeat and we get accustomed what the question is, what the answer is, well, then it's a no-brainer from there. Number 6. The locus of points described by a complex number z is given by, the locus describes a circle with, well, I know the radius going to be 3 for sure. Bradam. Now, we have to change this piece how it does look, right? So it needs to be modulus of z, take away something. So factorizing the minus 1 on the outside, I'll get 1 minus 2i. And the center is going to be, 1 plus 2i. And the center is going to be 1, 2 is going to be the center. So the answer for number 6 is C. Number 7. The complex number can be represented on an Argand diagram by, well, we go how to rationalize this, right? So 1 over 1 minus I, add and multiply by 1 plus I over 1 plus I. I'll move this. This is equal to 1 plus I on top over the denominator is a difference of 2 squares, which is going to be 1 squared minus I squared, which is 1 minus minus 1, which is 1 plus 1, which is 2. So the denominator is 2. I'll get 1 half plus 1 half I. So 1 half is going to be A. Number 8. If dy dx is equal to 2xy, then the value of, okay, so we have our product rule here. Let me see how best we can tackle up this product rule, right? Let me just center this a little bit. Why am I not centered? Right, much better. Okay, let's go. It's going to be v by du dx plus u by dv dx, which is going to be 1 by dy dx. dx. Cool. Now, they say if dy dx is this, right? So I just have to differentiate once to get the second derivative. So if this is dy dx and dy dx is 2xy, I'm going to get 2y plus 2x into 2xy, which is 2y plus 2x, 4x squared y. When x is 1 and y is 2, I'll get 2 into 2 plus 4 into 1 squared by 2. 2 2s are 4 plus 4 2s are 8. I'm going to get 12. The expression is equal to, well, I could rub this off. Alright, so this is a difference of two squares inside of here, right? This is a squared minus b squared. It's going to be a minus b, 1 plus I, take away 1 minus I, into a plus b, 1 plus I plus 1 minus I. I don't need to put the brackets for the plus because the plus wouldn't change anything. 1 plus I minus 1 plus I multiplied by 1 and 1 is 2, I minus I. So 2 here. 1 minus 1 is 0, so I'm going to get 2i inside of here. 2i by 2 is 4i. And we had to multiply that by the I on the outside, so we get in 4i squared, which is 4 into minus 1, which is minus 4. So the answer for this is A. Alright, so for this one here, we have to make sure we are in the form of the integral to just put it as a tan inverse, right? So we need to get it as the integral of f dash x over 1 plus f of x all squared. So I have to change how 9x all squared does look. So I'm going to get 1 over 1 plus 3x all squared. 3x is f of x. In order for me to integrate properly, my numerator needs to be the differential of 3x. So I had to multiply the numerator by 3, and I will have to divide it by 3 as well to make sure I change the value of it. So if I multiply by 3, I could also multiply by a third on the outside to make it look like the tan inverse, right? So this as it stands right now could be integrated. This is going to be 1/3 on the outside, and when I integrate this, I'm going to get tan inverse of f of x. So 1/3 tan inverse of 3x, the answer for this is going to be B. The integral of cos 5x plus cos 5x cos 3x is going to be, now if we remember the sums as products and differences or vice versa, that's going to help us out a lot here. If I recall correctly, cosine A, cosine B, so recall, cos A, cos B is equal to, it's a half cosine A plus B. Is it minus or plus by? I think it's plus. Cosine of A minus B. I think that's the correct one. This is equal to, we're going to have cosine 5x cosine 3x. That's a half cosine. A plus B is 5 and 3 is 8. A half cos 8x plus cosine 5 minus 3 is 2x. And then, oh, we don't even have to integrate it. They just want to know what it is equal to. So it's a half cos 8x plus cos 2x. So the answer is C. Ay. This is where Oligon and Cosma. Alright? When we calculated the square root of a complex number in the past, we had to go through the long working. All right, and then it had the shortcut I showed you guys. But still, the shortcut, it required us to remember not plenty things, but it would have been easy to miss something in the formula. So what I'm going to show you guys here is going to be a way to cut the time down tenfold. I'm going to change this complex number into exponential form, and then I'm going to put this complex number from exponential form into trigonometric form. So let me see what we're gonna do. We know that how I'm gonna do it right on top here, right? R going to be 5, right? The modulus is going to be 5, and the argument is going to be, let me see which part it lands, 3 minus 4, it landing down here, so it's going to be minus the reference angle, right? So the reference angle is going to be tan inverse of 4 over 3. Now that is not an exact value, so I'm going to put arg z as negative tan inverse of 4 over 3. That's the argument of this complex number. This is all I need to write down the exponential form of the complex number, which is going to be 5e to the I minus tan 4/3. That's the exponential form of the complex number. Now I want to calculate the square root of the complex number. Square root means I'm putting this to the power of a half. So this whole thing is going to be raised to the power of a half to calculate the square root. This now will be root 5, and e to the I tan whatever is going to be e to the I into minus a half tan 4/3. Tan inverse, sorry. Why am I doing it? Tan inverse. Cool? Now from here, I mean, this is familiar territory to us, right? From here, I'm going to throw this in exponential form. This is equal to root 5 into cosine minus 1/2 tan inverse 4/3 plus I sine minus 1/2 tan inverse of 4/3. Well, let's check and see what it is. Cosine, we're working in radian measure, right? So let's go back into radian. Cosine of minus a half tan inverse of 4 over 3, close brackets, is equal to this. And I had to multiply this by 0.5, by root 5. So this multiplied by root 5 given me 2. So it's either C or D. Cool? Next, we're going to calculate what sine of minus a half tan inverse of 4/3 is. Again, that multiplied by root 5 are going to get minus 1. So it's going to be, I'm going to freeze this on the screen. This is going to be 2 take away I. The answer is C. You could also square any of the options to see which one gives back 3 plus 4i, which is option C. Yes, you can do that as well. All right. So if we were to square each of the complex numbers, you could get back the option. Yeah, I know this one is real work, but I say let me still show all it, right? Because if I had shown all of this in the beginning to calculate the square root of a complex number, it would have cut down the work we did by a lot, quite a lot. All right. Next, this is a integration by recognition. We're looking at the integral of f dash x and f of x dx. So all I had to do is, this is equal to ln modulus of f of x. So I'm looking for ln modulus of tan x, and well, the half had to go on the outside, right? So a half ln modulus of tan x, well, we know is plus c, 13 is a. Aha. You see this here? The principal value. In the past, I would have shown you guys that the principal value lies in quadrant 1 all the time, which would have been a wrong analysis. That's why I decided to change the name of principal value to reference angle. The principal value of the argument of the complex number is going to be, let me get the argument of the complex number first. So argument is going to be tan inverse. Well, it wouldn't be argument as yet, right? Right now, this is in minus 2 plus. So it's going to be pi minus. So it's going to be pi take away tan inverse of 2 over 2. Tan inverse of 1 is pi on 4. So it's pi minus pi on 4, which is 3 pi on 4. This is the principal argument of the principal value of the argument of the complex number, 3 pi on 4. All right, number 15. Given sec squared, sorry, sec squared x is equal to 1 plus tan squared x. The integral of tan squared x over 4 is going to be, well, that will just be the integral of, well, I'll go put the quarter on the outside, sec squared x minus 1 dx. That is a quarter into, when I integrate sec squared x again, back my tan x, when I integrate 1 again, back x, between pi and 0. When I plug in 0, I'm going to get tan 0, and I'm going to get tan 0 take away 0. So we're going to get a quarter into, where's tan of pi? Tan of pi will be 0. Oops. Tan of pi, tan of 180 is 0. So we're going to get 0 take away pi, take away the whole thing gonna be 0 when I plug in the lower limit of 0, right? So we're going to get minus pi on 4. The answer is A. For n being between those two values, all right, so in this case here, we can see that we want the sum from 0 to infinity. So this is going to be sum to infinity formula. We need to get what A is, we need to get what R is. Now, given that, I mean, we could, let me do it manually, right? Let me beat around the bush and try anything smart. When R is 0, I'm going to get 2n to the 0 plus 2n to the power of 1. So I'm going to get 1 plus 2n. R is going to be 2n divided by 1, which is that, and A is going to be 1. So S infinity is equal to A over 1 minus R. 1 over 1 minus 2n. The answer is B. Good. The binomial coefficient NC4 is equivalent to, I know it can be the first one for sure, right? Ooh. Okay. Take a look at this, right? We know that how NCR, is n factorial over n minus r factorial by r factorial. If you want, we could go through this, but watch this. If I have NCR, n have to be greater than r for choose 2. I can choose two things, to choose 4. I can't choose 4 things from 2 things. So I'm comfortable n had to be bigger than r. Yeah? Over here, n take away 4, that's smaller than n. So I point out here, n take away 4 is smaller than n. So u can work. Over here, n is still smaller than n plus 4. So this can work here. Over here, n is indeed bigger than n minus 4. So this is what we're looking at. Right? Easy peasy. Given that u sub n represents the nth term of a sequence, which of the following converges? So we can women have to have 0 on the bottom. Yeah. Another way is to just test the limit. So let's check and see the limit as n tends to infinity. This one here will go to infinity for sure. This one will also go to infinity. So this one will go to infinity. This one will also go to infinity. When you have the powers, this will also go to infinity. But this one here, when I divide both by the highest power of the variable, I get 5 over n take away 3 over 2 over n take away 1. And I will get 3 to be the limit. So this one here will be converging. So if the limit is equal to some constant k, I have the function or the sequence converging. Alright, so this has a root between, so let me check and see. We had to check and see f of 0 by f of 1. F of 0 by f of 1 go in a calculator. We're looking to see which one is less than 0 by intermediate value theorem, right? E to the 0 is 1. So 1 take away 0 is 0. Well, this is equal to 0. So that can happen. F of 1 by f of 2 are going to get e to the power 1 take away 1 to the power 4 is 1. I'll store that in a, and then e squared take away 2 to the power 4, and I'll multiply that by a, I get a negative. So this is less than 0. So B is my answer. The sum to infinity of a geometric series is 1 over 1 minus 2x. The range of x is, well, we know that the sum to infinity only exists a over 1 minus r if the modulus of r is less than 1. So all we are going to do, we need to take the modulus of 2x. So the modulus of 2x needs to be less, this is between minus, from here, minus 1 will be less than r will be less than 1. Yes. So here will be minus 1 will be less than 2x. Could be less than 1. Minus a half is less than x is less than a half. Let a sub n and s sub n denote respectively the value of the nth term and the nth partial sum of a series. The value of s sub n plus 2 take away s sub n when calculated on the series is. Alright, so s sub n plus 2, let me expand it out and see what we get, right? S sub n plus 2 going to be a1 plus a2 plus all the way up to an. I will include plus in an because of this s sub n here, plus an plus 1 plus an plus 2. That are the next two terms after a sub n. And s sub n is going to be this here. So when I take away, I'm going to take away everything there, and I'm remain with a sub n plus 1 plus a sub n plus 2. So the answer for this is C. Alright, partial sums. Let's see what goes on here now. Yeah, I'll go see if I have enough space to do it down here. I mean, method of differences. So when r is 1, I'm going to get 1 take away a half. When r is 2, a half take away a third. When r is 3, a third take away a quarter. So I see the first term surviving. If the first term surviving, then the last term will survive. When r is equal to n, we get 1 over n take away 1 over n plus 1. So first term survives, last term survives, everything else will cancel out. And I'm going to get 1 take away 1 over n plus 1 is 1 over everything, right? I'll get n plus 1 take away 1 all over n plus 1. 1 take away 1 is 0, so I'll get n over n plus 1. The answer is D. Given that the sum from k to n is s sub n, if m is less than n, then the sum from k starting at m plus 1 and ending at n is going to be, okay, so let's take a look and break it down with an example here, right, just so you all understand it. If I have the sum of a series and I start at 1, and let me say we ending at n, I can break this up as the sum starting at 1 ending at, let me say, 4, plus the sum starting at 5 and ending at n. So when I combine these two here, I'll have the first 4 terms here, and then I'll have from the 5th term to the nth term. So I'm going to change around these things, right? The sum when k starts at 1 to n go be, if I start at 1 and I end at m, and I could start at m plus 1 and end at n, because when this was 4, this was 5, so I'll have to add 1 to this to start my next summation. Well, from 1 to n, if that is s sub n, this is s sub n. From 1 to m, that is s sub m. And this here is what we want. So all I had to do is throw this on this side here, Sn take away Sm. Answer is C. 24. The coefficient of x to the power 4 in the Taylor series expansion of cos x about 0. So f of x is cos x. The coefficient of x to the power 4, right? So f dash x is minus sine x. F, the second derivative is going to be minus cos x. The third derivative is going to be sine x. And the fourth derivative is going to be cos x. So we know that out. The power of x to the power 4, if you write out your Taylor series expansion, we're going to get f, the fourth derivative, into x minus a to the power 4 all over 4 factorial. This will give me the coefficient of x to the power 4. So when x is 0 over here, I'm going to get 1. So I'll get 1 into x minus 0 to the power 4, which is x to the power 4 over 4 factorial. 4 by 2, 4 2s are 8, 4 by 3 is 12, and 12 by 2 is 24. 24 by 1 is 24, so 1 over 24 will be my coefficient. The value of the term independent of x in the binomial expansion is NCR a to the n minus r b to the r. This must give me the term independent of x, which is going to be x to the power of 0. So a to the n minus r is going to be x squared to the 12 minus r. B to the r is going to be 1 over x to the power r is equal to x to the power 0. So this is going to be x to the power of 24 take away 2r multiplied by x to the power minus r is equal to x to the power 0. Equate up the powers. 24 minus 3r is equal to 0. Move the 3r across, and r is equal to 8. So the term independent of x is going to be 12C8. Now, I don't have a 12C8 here, but that doesn't mean we make a mistake. All right? There are, because of Pascal's triangle, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and so on. You see how this number and this number is the same? These are the coefficients in the expansions. So this is going to be my NC1, and this is going to be my NC2. This is going to be my NC3, and so on. Cool? So NC1 and NC3 are equal to each other. I just given a general example, right? They don't have to be NC1, NC2, and so on. But what I'm trying to get at you guys is, in the expansions, some of the coefficients are indeed equal to each other. So I have to check and see which one is equal to 12C8. So let me check and see. 12C4. Well, first 12C8 is 495. 12C4 is 495. So the answer is A. Which of the following statements is true? Now, so A cannot be true. I cannot just bring a r squared to be in a power in front. I can't do that. This one here, this is not true as well, because let me just pretend, right, that the series for the r squared, I get 1 squared plus 2 squared plus 3 squared. Is this equal to 2 into 1 plus 2 plus 3? It's not equal. So that's just option A. Is this equal to 1 plus 2 plus 3 all squared? It's not equal to that either. Part C looking good. This is, if I break up the summation of a constant when r starts from 1 to n of a constant c is just c multiplied by n. So the summation of the constant 2 will be 2n. And the summation of r squared is summation of r squared. So C looking like the correctest one. And let me just check part D. Part D says when I have r squared, that is r squared, and I've taken away 1. So the third one, or rubbing off these two on top here, the fourth option says it's going to be r squared minus 1, which is going to be 1 squared minus 1, plus 2 squared minus 1, plus 3 squared minus 1, and that's not equal to each other as well. All right? Number 27. If the coefficient of x cubed in the expansion of this is negative 84. So the coefficient of x cubed in this expansion is negative 84. We're going to have to go with NCR again, right? NCR a to the n minus r b to the r is equal to x cubed. I'll take a to the n minus r, which is 6 to the n minus r, that's not going to make a difference. All right. What's going to make a difference is going to be minus ax to the power of r is equal to x cubed. I'm not even concerned with the minus a. X to the r is going to be x cubed, so r is going to be 3. When r is 3, I'm going to get 9c3 a to the 9 minus 3 minus ax cubed. The coefficient of x cubed is negative 84. The value of a is, so we had to go and calculate what this coefficient is on the left hand side. 9c3 multiplied by 6 cubed, 18,144 multiplied by minus a cubed, so I'll have minus a cubed, x cubed is equal to negative 84. Divide both sides by 84. The minus signs go cancel. And the square root of 200 and the cube root of 216 is going to give me 6. So if a cubed, this is going to be when I divide 216 a cubed is equal to, when I divide both sides, it's going to be 1, and a cubed is 1 over 216. The cube root of 216, the cube root of the answer is 6. Here will be that. 9 minus 3 is... did I make a mistake? It's supposed to be... Okay, I seen my mistake. 9 minus 3 is 6. It's going to be 6 to the power 6. So I make a mistake here, right? So 9c3, I'm going back on my calculator. 9c3 84 multiplied by 6 to the power 6. I did 6 cubed before. Now, is this multiplied by minus a cubed is equal to minus 84. So I'm going to ignore the minuses, because when I divide both sides by minus 84, I get any plus. I divide it by 84, and then I find in the cube root of the fraction. So when I cube root this, it's going to be 1 over this. 36 is going to be 1 over 36, which is E. I'll follow that. Just how I made the mistake just now when I had 216a cubed. Instead, I'm going to have the big number a cubed. Rearrange it. I'll get 1 over the big number is a cubed, and I'll cube root both sides to get 36 on the denominator. The sum of the infinite geometric series 1 a over 1 minus r, which is 180 over 1 minus 60 divided by 180 is minus a third, so minus a third. 1 plus a third, so 180 divided by 1 plus 1 third, 135. Agreed. The values of x for which the expansion is valid. Agreed. Alright. I mean, no big deal. Let me bring it on the numerator, right? We're going to get 100 minus 50x raised to the power of negative a half. I want the first number in the bracket to be 1. So what I'm going to do? I'm going to ignore the minus a half for now, and I'm going to factorize out the 100. I'll get 100 into 1 take away 50 over 100 is 1 half x, and I'm raising everything to the power of negative a half. Regardless what the regardless what this is, this has no effect on the validity of the statement. This is the only thing that we need to test. This is going to be valid for minus 1 is less than minus a half x is less than 1. Multiply both sides by 2. Minus 2 less than minus x is less than 2. Multiply both sides by minus x. I'm going to get minus 1, sorry. 2 is greater than x is greater than minus 2. Bring the minus 2 back on the left side. Minus 2 is less than x is less than 2. The answer is B. A continuous function is defined by f of 0 is that and f of 0.8 is that. Using the first approximation to the root to 3 decimal places, using linear interpolation. So linear interpolation is going to be a modulus f of b plus b modulus f of a over f of b plus f of a, the modulus, and the modulus. So this is a, this is b, modulus, modulus, we gotta take those two things there, right? Right, I mean, once all I do now, we're supposed to know what I'm talking about. So a by modulus of f of b, which is 0.76, plus b by the modulus of f of a, which is 1, all over modulus of f of b is 0.76 plus 1. So we're going to get 0.8 over 1.76. 0.8 divided by 1.76 is 0.454545. And I want it to 3 decimal places. So 1, 2, 3, 0.455. 0.455. If M is that, the first row of the cofactor matrix. Alright, so the first row, cancel out these two things here to get the first number. 24 take away 5 is going to give me 19. So this is the only one that has 19 here. This have a negative 19, so we just have to make sure that the sign matrix lines up. And the sign matrix for the cofactors is going to be plus, 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 plus. Everything else turns to minuses, right? So the first entry is going to maintain its positive. So the answer is going to be C. The determinant of the matrix, so it's going to be 3 multiplied by the determinant of this matrix, which is 4 3s are 12. Take away minus 10, which is 12 plus 10, which is 22. Take away minus 1, which becomes plus 1, by the determinant of 4 2s are 8, 0 by 2 is 0, 8 plus 5 multiplied by 5 2s are 10, 0 3 is 0. 66 plus 8 plus 50. 6 and 8 is 14. There is 74 plus 50. 7, 8, 9, 10, 11, 12. 124. The answer is D. Two coins on a die with faces numbers 1 to 6 are thrown once. Assuming that the die and the coin are fair, the probability of obtaining less than 2 heads and a number less than 4 is. Alright, so we had to draw a possibility space diagram for this. So 2 coins. We could get a heads, our heads, our tails. So we only want the two heads, right? But we still had to get the total number of possible outcomes. 1, 2, 3, 4, 5, 6. So heads, 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 tails, 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 and then tails, heads. Total possible outcomes is going to be 6 by 4, which is 24. The probability of obtaining two heads, which is this column here, and a number less than 4, which is going to be these 3 here, that's going to be 3 out of the 24, which is going to be 1/8. Given that y is 0 and x is 0, the general solution of the differential equation, I jump on the calculator, solve the auxiliary equation, 169, this is a perfect square, minus 3 is the only answer. And for for real and equal roots, y is equal to ax plus b e to the mx. And then they say that our y is 0 and x is 0. So if this is 0 and this is 0, that is going to be 0 plus b into e to the power 0 is 1. So I'm getting b to be 0. So if b is 0, I'm just going to get axe to the minus 3x. In this case here, a is just a constant, so a could be replaced with b, which is just a constant, so the answer is going to be b. If marbles are chosen without replacement from a bag of 10 blue and 5 red, so that 15 marbles in total, the probability of getting a red marble followed by 2 blue marbles is, so a red marble will be 5 out of 15 multiplied by, we take out 1 from the bag, so we get in 14. We take out 1 from the bag, so we're going to get 13. 10 blue, it will be 10. And we take out the blue and we leave it. So 5 by 10 by 9, 15, 14, 13. The answer is A. A school debating team comprising 3 teachers, 3 boys, and 3 girls is to be chosen from 5 teachers, 4 boys, and 6 girls. The number of ways the team can be chosen is, so teachers is 3 teachers from 5 teachers, 5 choose 3. 3 boys from 4 boys, 4 choose 3. 3 girls from 6, 6 choose 3. So 5 choose 3 by 5 choose 3 by 4 choose 3 by 6 choose 3 is 800. The answer is D. If m is that, then the cofactor element 3, the cofactor of the element 3, so this was this one here, so cancel here, is, so the one was the determinant 1405. So we have 1405 here and negative 1405 here. Based on the position of this here, it's going to have a minus in front of it. So the answer is going to be B. The number of possible values of x which satisfies the system of simultaneous equations 2x plus 3y plus 2, 4x plus 6y plus 4z, 10, 25. So if you realize, if I multiply by 2 again this, if I multiply by 3 again this, so I can see that all are parallel. Since all are parallel, the number of possible values of x is going to be 0. We wouldn't have no solutions because they are parallel. A, B, C, and D are 4 3 by 3 matrices. So A, B is that, B, C is that. Alright, so they give us a whole set of multiplications and representations, right? At the end of the day, we want to know what A by B by C by D is. So A by B is J, C by D is L. Is J L an option? No, it's not. So we can't go with that. Look at the next one. ABC is P. So ABC is P. So P by D. So PD looking at the answer. 38 was A. A suitable integrating factor for the solution of the differential equation is, so it's going to be 2 over x, so it's going to be e to the integral of ln 2 over x, which is going to be ln oh damn. Now e to the ln, e to the integral, oh no, it's e to the integral. Why put e to the ln? It's e to the integral 2 over x. My bad. This is going to be 2 ln modulus x. So 2 ln x. Move the 2 on top. I'm going to get e to the ln x squared. The e and the ln could cancel, and I'm going to get x squared to be my integrating factor. The general solution of the differential equation is, alright, so this is variables are separable, so dy over y, is dx over x. So we're going to get ln y is ln x plus c. None of these are answers, so I'm going to change how the constant does look. I'm just going to put the constant here is k, so I'm going to put ln k. Alright, we can do that. So this is going to be ln y is equal to ln kx. So y will be equal to kx. So the answer is B. Just remember, you can change how the constant looks to make it look anyhow you want it once it's a constant. Alright, next, 42 refers to the Venn diagram, which shows the probabilities associated with events K and L in a sample space S. The probability that L occurs, given that K occurs. So L occurs given that K is L intersect K divided by K, which is equal to 0.15 divided by K is going to be 0.45 plus 0.15 is 0.6. 0.15 divided by 0.6, 0.25. So the answer for this is E. Okay. Chad, Matthew, Josh, Paul, and Tiffany are traveling in a 5-seater car with 3 persons in the back, 2 persons in the front, and each person occupies a seat. The number of different ways they can sit in the car if Tiffany sitting in the back and Josh driving. So if Tiffany sitting in the back, right, and Josh driving, we had to sit down 3 people. So Chad, Matthew, and Paul, we had to sit down them 3 people. The number of ways I can seat those 3 people is going to just be 3 factorial ways. Cool? Now in the back seat, it are three seats in the back seat, right? So one of the ways, Tiffany could sit down in one of those seats. So that means we will have 3 different ways to seat Tiffany. So we have to multiply this by 3. Josh already driving, he in the driver's seat. 3 factorial by 3. 3 by 2 is 6. 6 3s are 18. the general solution of the differential equation. Okay, let me go ahead and solve this. Let me solve it right here now. M squared minus 3m is 0. M into m minus 3. So m is 0 and m is 3. So we're going to get c1 e to the 0x plus c2 e to the 3x. So c1 e to the 0x is just c1 plus c2 e to the 3x. So the answer is going to be C. They just change how c1 and c2 look. And lastly, the matrix A represents a system of linear equations after some elementary row operations have been performed. Which of the following statements is true? The solution is unique. Unique meaning it have one solution. There's no solution. That is indeed true because we have a row of zeros in our 3x3 matrix. Remember, this represents the x variable, the y variable, and the z variable. So this says 0x plus 0y plus 0z is equal to 2. That ain't making sense. That ain't making sense at all. So this has no solutions. Alright, it's not even if it have an infinite number of solutions. Can be that as well. Alright, and the solutions are dependent there. Alright, so that is 2018.